I had this interesting idea that I could maybe enhance the reasoning of a large language model by asking it to detect if there's some logic problem in the question I'm asking it. Then ask it to create some Prolog code for that problem, execute it, provide the output back to it, and then, use it as for the further reasoning, making essentially that large language model a better version of itself. Did that work? Well, yeah, but also OpenAI dropped O1 while I was creating all of it, and it just completely derailed my video. Let's see what happened. Let's start with this Alice in Wonderland paper, which I think was released in June, which explored how large language models are dealing with simple logic issues. They defined this trivial sounding problem, which any person can solve without any issues. Alice has M brothers and she also has M sisters. How many sisters does Alice's brother have? Simple, right? The answer is obviously M plus 1. The number of brothers does not matter here. So say Alice has 3 sisters, then the answer is obviously 4. The brother has same 3 sisters, plus Alice herself. So how did LLMs deal with this problem? Well, they were pretty horrible at it. Look, GPT-4o was the only one achieving about 60% success rate. And yeah, like 60% success rate, given how simple this problem is really not good enough. All the others were just plain bad. Not something you would expect from LLM. An entity was able to do all the wonderful things which LLMs are doing right now, but yeah, they were pretty bad at it. Also, there's this Alice in Wonderland plus problem, which, all the best models cannot get right seemingly almost at all. And we'll get back to it later. All right, let's try it ourselves first with GPT-4o, which, remember, is the best performing model for the original problem at 60% success rate. I'm not going to do a huge trial, but you can see how is it going. It's pretty bad. The paper also used several prompt types, which we can also try, but in my experience, they don't really change that much. So where do I come in? Oh, okay, we have tools to help with that, by the way. One of them is Prolog, a declarative language where you can declare facts and rules and then write questions or queries to it, which will be answered using those said facts and rules. I'll show you how it works just very quickly. Let's say we think of an idea that Alice can only be happy when the rabbit is sad. In Prolog, you would write it as happy Alice is sad rabbit. These symbols right here denote an if. And this is enough for us to execute this query. Let's launch the interpreter. Happy Alice? Now, no. Why? Well, because this rule does not have enough facts to make Alice happy. Rabbit needs to be sad, right? So let's create this fact, sad rabbit, execute this again, and yay, we just made Alice happy. And that's all there is to Prolog. You can consider yourself an expert. Do not get overexcited with way more to Prolog. Let's try asking GPT-4o to use this wonderful new tool. By the way, in order to do this properly, we need to agentify GPT-4o, meaning taking several steps, asking it to identify the logic pieces, writing the Prolog rules and facts separately, entering these rules and facts to Prolog database, then asking GPT-4o to write a query, execute the query, present the outcome back to it, and only then we can ask, for the final answer, which in process kind of makes it an agent. But I've already done that multiple times in my other videos, and I will not show you any of this. Let's do it a bit simpler manually this time. Please write down all the facts in Prolog. And lo and behold, GPT-4o produces me perfectly reasonable Prolog code. Also, it goes a bit further. GPT-4o is so verbose, it always does that. But anyway, let's just check if it's correct. Well, again, very verbose, but all the facts seem to be in order. The crucial fact which GPT-4o seems to miss with its reasoning when answering the question is the fact that Alice herself is one of her sisters. So it's this fact, by the way. Alice is a sibling to brother 1. That's important. Everything seems right. Let me show you around. So let's focus on brother 1, since brother 2 is essentially identical. Here's all the siblings brother 1 has. Brother 2 is also a sibling. That might be a problem, But we seem to have further facts to help deduce that brother 2 is not one of his sisters. Here, everyone is, of course, a person, but brother 2 is male, while Alice and other sisters are denoted as female. So it seems to be enough, of a facts to determine the answer. Also, there's a rule. I didn't ask for the rule, but it gave me anyway. Again, GPT-4o. It's really a predicate to help find all the sisters of any person. It uses Prolog's meta directive find all, which I won't get into, but basically it can find all the sisters of a person. Please note that everything with a capital letter uppercase, these are variables in Prolog, and that's always denoted by uppercase. So we read it as this. You can be considered to be a sister of a person if and only if you're the sibling to that person, plus you're the female. Sisters, that's just a variable to put the result in. So let's put it all into a database, which is just a file, then load it in an interpreter, and but what's the query? Here it is, and hey, it's amazing, and it's indeed 5. Amazing. But by the way, look at this. This is crazy. GPT-4o kind of thinks that it should actually return 4 based on its own reasoning. That's funny. Let's now tell it what it actually returned. Okay, I executed this Prolog query, return n equals 5, and look, GPT-4o comes back with the most amazing line possible in a Nietzsche-esque manner. If the facts are contrary to my opinion, so much the worse for the facts. It suggests fixing the Prolog code to accommodate for that. Yeah, I'm not gonna do that. Look what it says. The result should be n equals 4, which is the correct number of sisters Alice's brother have. He's so sure, right? It's just hilarious. Let me humbly suggest that n equals 5 is the actual correct answer. And look, it forces GPT-4o to kill the inner Nietzsche in itself and accept it. That's actually good. So, hey, should we start deploying Prolog interpreters next to every large language model? Well, there's more hurdles to clear here. I'm writing no papers, meaning my sample sizes are abysmal. There's also a separate problem of identifying logic puzzles in larger contexts, right? Isolating them. But still, it's a promising technique. The reason I would not go all in with it right now is different. So in the middle of a process of me writing the code for the agent to improve GPT-4o to unseen heights, OpenAI dropped O1. All right, let's pose the same problem to O1. This looks way better. Okay, overall, it's a huge improvement. Do we no longer need Prolog? Wait, all hope is not lost. Remember, this problem is quite simple, and the paper had this Alice in Wonderland plus problem, which is way harder. And remember, all the other models were just crazy bad at it. Let's look at it. So I'm not going to read it. You can pause if you want to and solve it for yourself. But just note, again, it's pretty trivial for humans. It needs slightly larger amount of short-term memory to calculate. And look, there's essentially 3 components to this, like 3 parts. We need to count all the cousins, and we need to think of mom's sister, Alice's aunt. She has no kids, right? But we need to calculate the number of nieces and take away Alice and her sisters. I think the hard point is probably this one, because dad's brother has a son, which kind of needs to be added separately, right? So in this problem, the final answer should be 3. Let's see what O1 is thinking about that. And remember a few months ago when this paper was released, this was totally unsolvable. Oh my, just look at that. One maternal cousin, paternal cousin, accounting for the uncle's son. Wow. Okay. And it did it without any prompt engineering techniques. I just gave it the problem. I didn't ask it to think. It knows on its own it needs to think, right? But this is crazy good. Where does it leave me with my Prolog-powered super LLM? Well, it pretty much leaves me in the recycle bin of history. Prolog was fun to do, and it really showed a lot of promise. And we might have to go back to it. Not all hope is not lost. But at the same time, I just keep forgetting at what speed large language models are actually progressing. You create some new tech, in few weeks, maybe hope to monetize it and get absolutely destroyed 1 week further. That's crazy. Anyway, thank you for watching. Hope you learned something. See you next time.